One thing that's worth noting is that these bivalves, these mussels and streams, are some of the most imperiled animals on the planet. So if you look at the kind of list of species and the species that have been impacted by the groups of species that have been impacted by the most decline, first is actually aquatic snails, and then the second is freshwater mussels globally. They've had a global decline, and so many of the species we have in North Carolina are and actually the majority of them are endangered or threatened in some way. So they're basically a biological monitor, and in this case, unfortunately, with these mussels, the main way in which they've been a biological monitor is us detecting the fact that a lot of them have died. And so this gives us the opportunity to monitor them over time before you actually see mortality in the population. Not everything occurs as a single bolus or a single event. Let's say there's something moving into the system over time and these animals are declining in health. One of the things that occurs is they lose their ability to close their shells tight. They may have their adductor muscles may be impacted in such a way where they can't close completely and they would stay open and gape. And just before they die, actually, that's what we see is they'll open up and they'll stay open for an extended period of time and gape before they actually die. What's really nice about what Alper and his students have done is they'll be tethered and they'll have some ability to move in the substratum. The equipment that we've used in the past, they were fixed on these pedestals and they weren't able to reflect their natural movement in the system. So it won't be a completely reflective of their full range movement, but it'll give them some opportunity to move as if they would naturally. Right. Now, there may be times that they are all feeding. There may be times that they're all synchronously not feeding, maybe in the evening, at night. But because we're developing baseline values for these animals, we can see whether there's an abrupt change in their behavior uniformly.
We have an accelerometer, the sensor that we use in the smartphones when the screen rotates. When the phone rotates, the screen rotates too. And we try to use this to read the body language of the animals. We used as an animal behavior monitor, and Jay contacted us and asked us, what can you we have such a problem. We are trying to monitor the behavior of the animal, and it's an indication of health. And it also can be used to use the animals maybe as an environmental sentinels, and just replace it with an accelerometer. And it also has a gyroscope and a magnetometer inside it, which shows every motion of the animal with respect to itself, plus with respect to Earth's magnetic field. We actually built a data acquisition system around that. So instead of having one, we had a multiplexer and a data acquisition system that can monitor from multiple animals. So we have a wireless data acquisition system, but it is connected to the sensors in a wired way. At the current stage of the project, we have a solar cell. Actually we have a pole that is stepped into the bottom of the water floor. Mm-hmm. And then it's a pole, and then on top of it we have the data acquisition system, which contains a solar cell on top of it to record the solar cell to harvest solar energy. And then we have a couple of environmental sensors, the relative humidity and temperature. These are extra parameters not needed for the experiment, but useful things for us. And then there's a wire inside the pole coming down, and from the side under the water we have this distributed around the pole. We have bivalves distributed. We are environmentally testing this system in EB2, between EB2's electrical engineering and computer engineering site. We have a nice balcony, and on that we have been testing this system. We have there are two parts of the system. One is underwater and sensors doing measurement, and the second system is over the water, and it is more of an outcome of a developmental effort more than a research effort, because whatever we use is commercial off the shelf. The solar cells, the data acquisition system, the wireless transmitter, and everything. So we are just trying to make it robust environmentally, because there's rain, there is humidity, some hot days. So the next stage is moving the experiments from our laboratory setup, which is in the balcony and our laboratory, into the Lake Raleigh to do some experiments.
Yeah, and we can learn some things about these animals that we don't know. So how do they respond to increases in stream temperature, lake temperature? How do they, what are they doing at night when they're in the system? Are they all closed at night? We don't really know that much about them. We do know that they move up and down and vertically and both horizontally in the substrate. But what are those cues that prompt that? We could be looking at environmental variables and then looking at the changes that we're seeing from the accelerometers to get a sense of that.